All right. Should we close the door? Yes, thank you, Cesar. Just a little bit of background noise. Okay, thank you. So, welcome everybody. My name is Mike Milinkovich, and this is my colleague Wayne Beaton. I think we know almost everybody in the room. Hi for the people that I don't know well. So we're here to talk today about the Eclipse Foundation Specification Process, and I guess it helps if you turn this on. And so this is the rough agenda, the background, creating the process itself. What do we mean by a spec? The actual process. And then, since many people here are familiar, or many people that are interested in this process are familiar with the JCP, so a couple of slides on what's different between the Eclipse Foundation Spec Process and the JCP, and then finally close off with some talks, some points on certification and branding. So background. So why the heck is the Eclipse Foundation doing specs in the first place? And it's sort of a opportunity meets necessity sort of thing, where we've been actually thinking about this for a while, because we're big believers that open standards or open specifications and open source are very complementary to one another. And but we actually were basically handed an opportunity that forced our hand when roughly a year ago it was announced that Oracle was going to be moving Java EE to the Eclipse Foundation. And as part of that, we needed a spec process to replace the JCP. But we already know that there are other projects within the Eclipse community that are interested in doing this. So we expect that this is going to be something that is going to be used elsewhere. So this is the Eclipse Foundation Spec Process. This is not the Jakarta EE Spec Process. Although pretty much everything we say here is going to be true of Jakarta EE, it is for use across the Eclipse Foundation, and we do expect that. we already know of other projects that want to do this. Whoops. So what's the big deal? Why are specs useful? And certainly you can meet folks in open source that'll say all you need is open source. You don't ever need to have a spec process. But specs do help in terms of collectively defining an idea. And I think it's very important to note that just because your open source code happens to be really cool and perfect in all ways because you wrote it, other people might have different ways or different opinions on how to implement something. And specs and the whole spec process is specifically designed to enable multiple implementations. And where as soon as you have multiple implementations, then allowing for interoperability becomes a thing, right? Because as soon as you have multiple implementations, then interoperability between those implementations is done through spec processes. So some guiding principles. Some guiding principles in terms of what we thought of when we were putting together the Eclipse Foundation Spec Process. First one is code first. And what do we mean by code first? So one of my pet peeves with the JCP since forever was, and you saw this more in the early days of the JCP, but this notion that, and this I'm exaggerating to make a point, but the very idea that the way to innovate is get a bunch of people in a room and write a spec, I think is inherently stupid. Not that I have an opinion, I just think that that's not how progress is made in software technology. The way that you make progress is that you experiment. You innovate first through writing things out. And I think I made this point previously is like, before I think something should be specified, there are two things that have to be done first. The first is you have to actually build something that demonstrates that it can be built. Right? You know, there's all kinds of things that you could write a specification for on a piece of paper that would either, maybe not impossible, but extremely difficult to build. So the first thing is actually prove that you can solve a problem. And the second thing you need before it's worth specifying is actually demonstrate that anybody cares. Right? Lots of people can write software that nobody cares about. But if you neither have written software nor demonstrated that anybody cares, why go to all the trouble of writing a spec? So when we say code first, what we're saying is we want to lead through innovation, through building open source implementations, demonstrating that somebody actually wants to use this stuff, and at that point, then, okay, let's talk about turning into a spec. Next guiding principle is, and this is sort of a delta to the JCP, is no spec lead. So no central control point for all of the IP that's involved in the specification. And basically, we want to create a vendor-neutral, collaborative process with no one company in charge. And that's that's really what, you know, if you read the JCP process, it never says, well, there's only a couple of places where it actually mentions Oracle, but it says spec lead a lot. It just happens that 99 times out of 100, Oracle happens to be the spec lead. So we were trying to come up with a vendor-neutral approach. We want to run specs as open source projects in a much more collaborative way, compatible implementations rather than one reference implementation. So in the JCP and in a lot of other places, you have like a reference implementation. So we're going with a notion that you need, you can have more than one, and in particular that means that you don't have a normative implementation. Self-certification and branding, and we'll talk about those. I'm going to hand the baton to Wayne for a little bit.
Okay. All right. So for the Jakarta EE specification process itself, our key deliverables for this year would actually develop this specification process and the compatibility process and brand licensing. So we actually do have a brand associated with the Jakarta EE specification. Sorry, the Jakarta EE. So implementations of the Jakarta EE specification will be able to use this brand. Anyway, so we're well on track to do this. We decided we wanted to start with the Eclipse Development Process. Eclipse Development Process exists. It's been used to successfully develop open source projects for many years. We figured we kind of knew what we were doing in that area, and using that as a basis seemed to make a lot of sense. It provides a lot of the governance and the structures that are actually required to do this work, and it does also have the ability, or leave much of the actual process to the individual project team. So day-to-day operations is really something that is specific to a particular project team, whether they, what form of agile process they follow or whatnot. The Eclipse development process is based around the notions of transparency, openness, meritocracy, and vendor neutrality. Actually, vendor neutrality, I should put a star beside it. That's actually not listed as an open source rule of engagement in this version of the current version of the Eclipse development process, but it probably will. Much of what we do is focused around making sure that a playing field is level, so that everybody gets to come and play by the same set of rules. Everybody has the same ability to participate. The Eclipse development process, if you were to formalize it, would look a little bit like this. And I'm just going to splash this up quickly because I'm going to compare it with some changes, compare what we're doing with the spec process later. There is definitely, we start with proposal, creation review winds up basically creating a project. Project goes into a development mode. They produce milestones. Those milestone builds over a release cycle eventually result in a release candidate that's sent forward for a release review. Then a project releases. Then they go into planning for their next release. Planning tends to be informal for a lot of our projects, but at various levels of formality. The Eclipse top level project, for example, does a great deal of advanced planning. So anyway, that just kind of snapshot that in your mind, because I'm going to show a similar diagram in a little while. The Architecture Council is going to be presenting the Board of Directors with an update to the Eclipse development process. We'll be doing that over the next couple of days. The meeting in November 14th is when the Board of Directors will have a chance to approve this for us. We've introduced the notion of a progress review, which will be valuable for the specification process. The progress review also will be not a replacement so much, but an alternative for projects to do releases. So just regular Eclipse open source projects can engage in a progress review, and then for 1 year after, they can do releases as they need to without further ceremony. They would still be required to follow the IP policy, which means all intellectual property would have to be cleared by the intellectual property team before that. We also took the step of formalizing the list of terms, which seems like it's a long time coming. Curiously, we really took a long time coming up with definitions of project and release. Turns out those are actually relatively hard things to define. We came up with some fairly concise definitions, though, which I'm happy with. So the Eclipse Foundation Specification Project extends this. We tried to take an approach of just enough process. We didn't want to keep it, we wanted to keep it lightweight. We wanted to make it so that innovation, the specification process itself didn't get in the way of innovation. We are introducing the notion of a specification project, which is just a designation. We have open source projects right now. This is just a special flag on a project. This also, and I'll talk more about this later, aligns projects with working groups formally, which is something we don't do with regular projects. And there's different approvals. Again, we'll talk a little bit more about that. And then we introduce the notion of participants and participant representatives, which again, I'll talk to in a few minutes. Did you want to do this?
Yeah, sure. You can tell we've carefully rehearsed this.
I know, it's just
Oh, this has a picture on it. I'm just kidding. So what do we mean by a specification? So a specification is a collection of APIs, descriptions of semantic behavior, data formats, and/or protocols intended to enable the development of independent, compatible implementations. Actually, the word independent there is particularly important. It's very possible to write a specification that's based on a particular implementation and tied to that particular implementation. But the whole point of the spec process that we're creating is the enablement of independent implementations. Even if there never is one, right? It's possible that you could do an open source project that just everybody loves and it's perfect in every way, and you still do a spec for it because it's useful. And if maybe nobody ever is motivated to create an independent implementation, but there's a certain quality statement inherent in saying that you want to enable independent implementations, right? If you do that, then the spec is going to be of better quality than something that's tied to a particular one. So the artifacts that we want every specification to include is there has to be a specification document. There has to be some technical artifact. That's actually kind of optional. But for example, in the context of the Java language, there should be a jar file that gives you the interfaces that you're defining in the specification, and you can pick up that spec document, pick up the API jar file, and go off and do an independent implementation. Then there also needs to be a TCK. And one thing that's sort of a subtle but important point is your implementation is not compatible to the TCK. Your implementation is compatible to the specification. The TCK is the mechanism by which you demonstrate that compatibility. Subtle but important point. And finally, like we said, there's no single reference implementation, but before you can say that the spec is final, there has to be at least one compatible implementation available in open source. So again, there has to be at least one. There could be 5, but before you can say the spec is done, you have to be able to prove to the spec committee that somebody is capable of implementing this and passing the TCK before the spec goes final. So the spec document, I probably just said everything for the next 5 slides. So the spec document is obviously text. There may be optional parts, but it must be possible to implement all optional parts. And there's actually I don't know if you have a slide for this, but there is a rule that when we say there has to be at least one compatible implementation, that compatible implementation has to implement all of the optional parts, right? So you can't go final when there's no demonstration that the whole spec is done. And if you include other specs by reference, you can't override those rules that are if it's been specified as non-optional in the spec that you're referencing, then you can't override that in your spec. So each spec has to have a TCK, and the TCK can be different for each versions. And the TCK has to be under one of the approved open source licenses, and we'll talk about what those open source licenses are in a sec. But again, the TCK is there to demonstrate that an implementation is compatible. And actually, brief comment on TCKs. One of the things that we think is going to be a fundamental difference between in the context of Jakarta in the future relative to the status quo today is the simple fact that the TCKs are open source is a huge differentiator, right? Like right now, if you're a Java EE8 licensor, it's incredibly, the TCK is incredibly confidential. It's so confidential that it's actually breaking the contract if you publish your results publicly, right? So the interaction between you and basically the interaction between you and the spec lead determines on whether or not you can claim compatibility, and all of that is done privately. We're expecting that because the TCKs are open source, the publication of results are going to be publicly available, that a lot of the behaviors that happen in the ecosystem are going to be open and transparent, and that's going to help everybody innovate. It's going to be a huge difference that if you see, if there's a test in the TCK that's bogus, right, the conversation about how bogus that is now going to be public, not some private conversation between you and Oracle. And that's a really, really big difference. So compatible implementations. So you have to be able to demonstrate that there's at least one. Again, has to be under an open source license, and we think that's important. So before the spec is done, there has to be an open source implementation. There can be other ones. Proprietary implementations are, perfectly fine, but you can't claim the spec is final based on one of those. And as I said earlier, at least one compatible implementation has to implement all the optional parts. So what do we mean by an open source license? So there's three: EPL 2.0 and only 2.0, the BSD 3 clause, and Apache. Those are the three choices. In the Eclipse Foundation Spec Process, it says that other licenses can be added at the request of that working group, and that would also have to be approved by the board of directors. Because the way things work at Eclipse is anytime we use a license other than the EPL, it needs board approval. The board has delegated to me the ability to also approve BSD and Apache as the executive director. But any license other than those three would have to be approved unanimously by the board. And I can pretty much guarantee you that if your suggestion is GPL 3.0, that's not going to fly. Yes, Dan.
Mike, I just a question. Aren't we also able to take to the board a request to remove one of these?
You would actually you wouldn't need to go to the board for that. If you want to remove one of those, you could do that at the working group level.
Okay.
You just can't add one without the approval of the board.
Okay.
So this is largely sort of being done for backwards compatibility. The JCP had this notion of there's specs, and then there's profiles, which are collections of specs, and then there's the notion of platform, which is sort of baked right into the JCP process. And really, from the way our spec process is these are all just specs. But a working group can decide that some spec, probably which is a collection of other specs, can be labeled as a profile. And there could be a choice by the working group to say there's a profile that's so extra special, we're gonna call it a platform. But these are basically branding exercises. But the one thing that's actually sort of special about profiles and platforms is that certainly in the case of Jakarta, the brand, the little sail ship, can only be attached to a profile or a platform. So the brand is not attached to a single spec. So you don't say, hey, we're servlet 4.0 compatible, and I'm putting the sailing ship on servlet. You have to have web profile or full profile or Jakarta EE platform. You have to implement all of that in order to actually put the sailing ship on it. So the spec process, I mentioned this before, just enough process. It's based on EDP. The IP flows are similar to the rest of the way Eclipse works. But patents are a little bit special because the way patents work in specs is different than the way patents work in open source licenses. And it's probably worth just taking a moment to explain that. So the way, say, the Apache license work and the Eclipse public license work is Yes, there are royalty-free patent grants in those licenses, but those patent licenses only apply to the contribution being made by that company. So IBM contributes code to the Eclipse IDE project. If there's any patents that read on that, it only covers that contribution in the context of the Eclipse IDE project.
It only covers IBM patents.
IBM's patents on that read on that contribution plus what was in the Eclipse IDE on the day they made the contribution. Right, so it's quite a narrowly defined patent license. The way specifications work, and this is not just unique to ours, this is basically when somebody says there's a spec, and this is why specs are different than open source implementations, is the way patent grants work in a specification context is if IBM is involved in a spec and they contribute to the spec, the entire IBM patent portfolio that would be necessarily infringed by any implementation of that spec, regardless of who does it and regardless of whether it's open source or proprietary, any implementation of that specification gets a royalty-free patent license to all essential claims that are owned by IBM. So as you can see, the patent licensing in a specification context is a much larger and broader patent license than what you get in open source licenses. And so that's definitely something that we've spent a lot of time thinking about and working on. And then finally, customizable means each working group that wants to do a spec process at Eclipse based on this spec process can slightly modify it within certain parameters, and it's mostly around making sure that they don't mess up the IP. I'll hand it back to Wayne.
So a specification, so we've introduced the notion of a specification project. It's a special type of project that is
They work better when they bounce.
Pardon me. Is designated as a specification project. It's owned by a particular working group. So we have an alignment there where specification projects are part of a single working group. They require for the different reviews that they engage in. Right now, PMC approval is required for most reviews. We require an additional approval of a specification committee. Specification committee is aligned with a working group. And we've introduced a special class of committer, which I'll talk about in a second here. So who's who? So I have a pointer here.
A little late.
I'm not going to touch it. I'm going to wreck something. I don't want to be like Denis this morning. So we have a specification project in the middle. We have the obvious group of committers and contributors along the bottom of this diagram. The PMC, it's up at the top. They're providing the governance and oversight. We've added in the notion of a specification committee. The specification committee is aligned with a particular working group. That specification committee does also provide approvals, like I said, on the different life cycle events of a specification project. They're part of the IP integrity equation as well. The other thing, I actually just wanted to include how companies relate here. There's actually no direct relationship between an organization or company and a project at the Eclipse Foundation. I deal in projects and committers and contributors and PMCs and that sort of thing. And organizations exert influence into this process by employing a committer. They exert influence by joining the working group and having participating on the steering committee. That's again with the more direct alignment between the working groups and the specification projects. There's actually there's a higher level of control for an organization in this equation. Specification committers. Now with specifications we have a few differences. So it's basically everything that a committer is on a regular project, but the committer must be a member of the Eclipse Foundation. Now to do that, the committer must either work for a member company or must themselves sign our member agreement as an individual committer. There's just some legal cover that comes with that. And they must also sign and or be covered by the working group participation agreement. Again, they can get this by virtue of working for a member company that has signed that agreement, or as an individual member committer, they can sign that document on their own. And that's the working group participation agreement is the one that's primarily concerned with patents.
Yeah.
The new notion of so one of the challenges that we have, and as Mike was suggesting, the way that the IP flows into a specification project is a little bit different. And one of the things we need to do is guarantee that an organization can stay involved in a project. So if a committer representing an organization retires, we need a way of immediately replacing them. So we've introduced the notion of a participant representative. I guess I should back up and talk about participants. A participant is an organization that participates in a specification. So an organization will assert that they care about a particular specification, and by so doing, they have the ability to basically appoint a representative onto the project. And that representative is becomes a committer, and they have all the requirements that I mentioned earlier.
I just wanted to add that, and the reason why this is necessary is because it's through this participation that ultimately binds that company's patent portfolio to the patent license grants that I was talking about earlier, right? So it would be unfair to say that Red Hat's patent portfolio is going to apply to this spec if they were uninvolved in the spec. And by putting a committer and by participating in the spec, that's the mechanism that binds their patent portfolio to the spec.
So I'm sure you recall in vivid detail the earlier version of this document. What has changed? And again, I put that document up earlier because I wanted, or that picture up earlier because I wanted to just sort of highlight that this looks really scary, and everybody I show this to kind of goes, and their eyes get really big. But fundamentally, it's not that different from what we do today. We have introduced a plan review. So proposal is created, project does a creation review. That creation review, that proposal serves as the plan for the first iteration. So we drop right into development after that, just like the regular process. Project will issue milestone builds and continue development throughout some number of milestones, which the project can decide, or maybe the specification committee and working group can make some recommendations in terms of how many milestones they produce. Some number of those milestones need to be taken through a progress review. That progress review requires approval by supermajority of the specification committee. That iteration, again, the way we've envisioned it, at least one progress review must be undertaken during development.
Right, and for those who are familiar with the JCP process, so you could choose to have a progress review and basically tell everybody that this is your early draft review. And so basically this is sort of an abstraction, but if you wanted to model the exact JCP process using this, you could.
So at some point we decide that we're done. We take a specification version. I'd call this this was a release candidate in the earlier document, to the release review process. That again, the specification committee gets a vote in addition to the PMC. That then results in the specification version becoming what we call a final specification or a ratified specification, and then the cycle repeats. That final line that loops back, there may be months, years, days, latency there, but the project would engage in planning for their next release. That plan then needs to be approved by the specification committee before it can be taken forward. So the spec committee needs to know at the beginning of a release cycle what the plans are and must approve of those plans. So there's a number of things the specification committee must approve. I'm going to actually power through because there's some things we need to get to in 6 minutes.
Yep.
We have some new versions of some agreements. I think I'm going to pass. Did you want?
Yeah, sure. I'll talk just for a second.
Like a minute.
Yeah. So yeah, basically, there's a couple of things we have to do for the IP flows to enable code-first development. And basically what we're going to say for both copyrights and patents is that if you give us stuff, you can't sue us later. So that is going to require a change to the Eclipse Committer agreement and the contribution agreement and the Eclipse Committer agreements and the terms of use. But it's all, I mean, of course it's written by lawyers, so it sucks. But all it says is if you give us stuff, you know, we can put it in specs and you won't sue us later, and you won't sue our implementers later. So it's basically just making it crystal clear that if you give us stuff, it's going to go into specs and don't complain later. So the JCP comparison. So it's a little bit harsh to the JCP to say their specification first. I would, because they have been doing more code first stuff, especially lately on the Java SE side with basing their stuff on OpenJDK. But certainly their roots of the JCP go back to a sort of a spec first kind of attitude. The executive committee of the JCP is does a mixture of what we have in both the steering committee and the spec committee. I think the way we're doing it, particularly in Jakarta, is a lot cleaner. So what used to be called an expert group is now going to be called a specification project. Experts are now specification committers. IP flows through the participants versus the way it works at the JCP where it goes through the spec lead. And both, the JCP has actually got pretty high marks in terms of transparency and public communication. So I think we're pretty equivalent on that. Although of course at Eclipse, you know, everything has to be public. And then we also have this feature where working groups can slightly modify these things on their own. So the document is open source in our context, where the document can be closed source. It often is open source in the JCP, but it doesn't have to be. The JCP actually gives the spec lead the flexibility of choosing their spec license to a certain degree. The biggest difference, as I talked about before, is that the TCK is not only is it closed sourced, but it's proprietary and confidential. So that definitely is a big change. And then in the JCP, there's one normative reference implementation, whereas we're allowing for multiple compatible implementations. We both have the ability to create things called profiles and platforms. So that's backwards compatibility. So in terms of claiming compatibility, I can whip through this real quick, is this very special thing. So up until the point where the spec goes final, it's just open source, right? But at the moment where the spec goes final and it's ratified by the spec committee, then special things happen. So the spec document is pulled, perhaps turned into a PDF, and that spec document is then licensed under the specification license. The TCK is, there's a particular binary version of it that's going to be put under the TCK license, which then will allow you to enable, if you pass it, you can claim compatibility. And the important thing to understand there is what we're getting to is a world where the TCKs are completely open source and you can always make truthful statements that I ran this TCK based on this and I passed all of it. But you can't actually say, I am compatible with this specification unless you run the exact binary version of the TCK under the TCK license. So there's going to be a much more open, a lot more openness around that world. So we have spec license, TCK license, and a trademark license, and then we'll talk a second about the trademark license. So this is a bit about what we were talking about earlier about how these artifacts get transmorgified from being open source into being special once the spec is final and ratified. Of course, the compatible implementations are always under an open source license. And then there's a self-certification that happens that if you are fully compatible and it fully implements the final specification, fills all the requirements, then you can, and you publicly make available your TCK test results, then you can make truthful claims about compatibility. And then one of the biggest differences, last slide, is around the brand, right? So once you're compatible and you've demonstrated compatibility versus the TCK, then you can also use the logo. To use the logo, you have to sign the trademark license agreement with the Eclipse Foundation, and we're not going to charge royalties or license fees for the trademark. But you have to be a member. so that you have to be, putting a little skin into the game in terms of making this all sustainable. But it's not like we're going to be licensing and getting deeply involved in your business.
Is there a minimum level of membership?
Solutions member. Yeah, it's not strategic, right? So if you're like a 2-person startup and you wanted to brand your implementation as Jakarta, it would cost you $1,500 a year. So the takeaway, so we're code first, transparent, community oriented in terms of, and by that we mean we're expecting the community to help us police a lot of this, and some of the behaviors that we're anticipating are based on, open community conversations about things. We think it's lighter weight. It's certainly not zero weight. This is not the GitHub of specifications. There is some work that has to happen. But we still are applying the rigorous IP management that the Eclipse Foundation is well known for, and we're building on the success of the Eclipse development process. We've demonstrated that we've got something that works, and so we're going to keep using that wherever appropriate. Perfect questions in your hand, like wow, yeah, exactly.
My time.
Yeah.
I see like an ordering issue. Because you have the specification, the TCK, and the compatible implementation. But you basically, they all three have to finish at the same time.
Yep.
But you can't be compatible unless you pass a final ratified TCK. So how do you square that circle?
It's going to be like a 2-phase commit kind of thing, right? So basically, they're going to be running the open source versions until we all kind of settle down, and then we're going to do like the way it'll work is we'll deliver to the spec committee. Here's the spec. Here's the TCK, and it's all version managed, right? And then here's proof that there's an implementation that passes this TCK.
Right, but it can't be called compatible because under your definition of compatible, it has to implement a final spec, which doesn't exist, and pass a final TCK, which doesn't exist.
So we're going to provide evidence to the spec committee that all of this works. They're going to ratify it, and poof, it's now a compatible implementation.
Okay.
Right,
so what
they run it again.
It's like you go to, you take communion, you're transmogrified. It's like, it's.
So one of the issues I see with that though is in OSGI, as we work with Apache on implementations, they have a policy that they won't make a final release of a thing until there's a final jar file with the final specs in it, right? The interfaces of the API, right? And so.
Actually, that's actually easy. I think that
no, because you can't as Eclipse, you can't publish a jar that has final APIs until you have a final spec. And so
actually,
can't give you a compatible
actually, so that's actually where your assumptions don't work. So what's going to happen is there's going to be a 2-phase commit on the project through the spec committee. So the project is going to do a standard Eclipse Development Process release review, and basically say we're done. And so the APR jar file will be versioned and final from the open source development process point of view.
And you can push that into Maven Central.
People can push that to Maven Central, and then it goes to the spec committee.
Okay, so then there's some effort for Apache, for example, to finish up, build, and test their implementation TCK, and the whole WAD gets delivered to the spec committee.
Exactly, and the fact that this works is a happy accident because we hadn't thought of that use case or that particular requirement.
Well, this is the problem we face in OSGI. We released the spec and we have to wait.
Oh, you did?
Yeah,
awesome.
We worked through this.
Okay, perfect.
I totally worked through this.
Okay,
and
awesome.
Exactly that way. So.
Hi.
So I perfectly understand where you come from the low spec lead, especially from the IP side, but I'm still a bit puzzled with this wording from the people doing this stuff. Of course, the committers that doing the specifications should be contributing, but at the end, we always have someone who's doing more work than many others in it, which is sort of the spec lead.
So actually, you're exact. It's a good question. Let me try answering, and then Wayne's going to tell me what I said wrong. So Eclipse projects have project leaders, right? So there is going to be a specification project leader. And that person may or may not work for some company, but they have special responsibilities under the EDP. So there is going to be a role for leaders in this context. The big point and the most important point is the spec lead concept in the JCP is tied to IP flows, right? And superpowers. A project leader in Eclipse is a position of responsibility, not a position of authority.
I completely got that. I think
Yeah, you get to work
puzzled
extra
is
hard.
The fact that on the slides you say no spec lead, but did not say but a project lead.
Okay, so
So this made the impression like there is no more project lead on one of these specs. and
yeah, and so to be honest, we kind of did that a little bit on purpose for exactly because if we put, oh, there is a specification project leader, people will go, aha, there is a spec lead. So and that really the role is really different, even if the names sound vaguely familiar.
yeah, no, I completely got that with the IP flow. This is
Yeah.
not what I'm questioning.
This is
Yeah.
an FAQ entry.
Yeah, exactly. Jan?
One question to running the TCK at the end. So I copy the TCK, run it against my implementation, and say works on my machine. But there's no central proof that this is compared or checked against the right TCK version, not the tweaked one I run to fulfill the requirements.
No, that's not true. So if you're going to make legal claims of compatibility, you will have to run a particular binary version of the TCK that is going to output a timestamp or something that says it's this one, and that's going to be visible in your public when you publicly disclose your TCK test results. So now you can run the open source version of the TCK and say things like, I ran this version of the TCK and I passed all of the tests. That's a truthful statement, and you can always make truthful statements. But if you want to claim compatibility with the final version of the spec, you have to run the special binary version of the TCK, and only that one.
And make it public.
And make it public, the results publicly available.
Some cryptographic
Yeah, it says,
algorithm to check that is.
yeah, like a SHA-1 or whatever, like
Sure. Implementation detail.
implementation detail.
But
Yeah.
I don't have to upload it to.
No, so we decided specifically that we don't want the Eclipse Foundation to be sort of the central clearinghouse. It's a consciously designed self-certification process.
Mike, I think we're out of time. I
Yeah.
think we should take this offline and out of the room. So we're here.
Yeah,
all
anybody who
week.
wants to leave can leave, and we can keep.
Well, someone else wants to use the
I
room.
think we're on break now, actually.
No, it's on break, yeah.
Time.